So here, as we know, since it is a circle, the signal received in any direction, okay, let it be any direction, horizontal, vertical or any particular angle, will be maximum. Thus, CP design, okay, circular polarized design will always lead to a minimum or zero signal loss, and that's why circular polarized antennas are required. Now, then can we design any antenna as a circular polarized antenna? No. The answer is no. The reason is there are certain conditions to be satisfied onto the antenna to realize a CP condition. So now we will talk about what are those conditions those realizes circular polarized antenna. Now in practical world, okay, in practical world, most of the antenna, microstrip antenna designs are elliptically polarized, okay, whereas linear polarization and circular polarization are the special cases of the elliptical polarization. If you realize certain amplitude and a phase condition for the orthogonal vectors, you will get a circular polarization or a linear polarization from the elliptical polarization. So elliptical polarization is a more general case. Most of the practical antennas will have this. I will also try to correlate or give a relation between by looking at the surface current distribution or the aperture distribution of the antenna, one can judge what kind of a pattern in the sense what kind of a radiation pattern, end fire or broadside, or lower or high cross polar radiation pattern antenna will be obtained. So I will also try to relate a cross polar level with respect to the elliptical polarization, linear polarization and circular polarization. Okay, so now I will talk about what are the conditions which realizes circular polarization. For circular polarization, two basic conditions which are required are you should have orthogonal vectors Ex and Ey. You should have orthogonal vectors which are Ex and Ey. So your Ex and Ey component should be there. Next thing is their amplitude should be equal. Their amplitude should be equal. Next condition is with respect to the phase. The phase difference between, I will say a mod value, because my phi y can be more than phi x or phi x can be more than phi y. There is no such condition that only x should lead or y should lead. Mod of that should be integer multiple of pi by 2. Okay? Yeah, sorry, to be very precise, it is odd integer multiple of pi by 2. Then only you will realize a circular polarized condition. If either of these cases are not met, that means what? These two conditions are not equal, Ex and Ey. This phase condition is not exactly 90 degrees. Then you will have a elliptical polarization. Now first, because of this, it is very much critical to realize these three conditions. Why three conditions? First, there has to be orthogonal signals. So Ex and Ey, these are my orthogonal signals. They should be equal in amplitude. So Ex is equal to Ey. And the third condition is phase difference between them should be odd integer multiple of pi by 2 radians. Now to realize these three conditions of the antenna, it's very difficult task. Okay, if you just design a patch, excite with a given field location, not necessary you will get a circular polarization. We need to ensure that these conditions are met on the patch, on the antenna to yield a CP response. How that is done, those we will see later in the various techniques which I will describe. If any deviation from this occurs, then you will obtain a elliptical polarized antenna, or maybe a modification of that will lead to a linear polarized antenna. Now based on this, I will try to correlate now how a cross polar level is important in the radiation pattern measurement for CP design. Now remember, as I said, if my transmitter polarization is vertical and if my antenna polarization is horizontal, as I mentioned earlier, you will get a signal loss over here. Okay, but if my transmitter polarization becomes circular, then irrespective of what is the incident polarization, I will get a CP response. Now what exactly it means that on the patch, okay, on the microstrip antenna, okay, which is excited, I am now trying to correlate the aperture distribution or the current distribution with respect to radiation pattern. I should get a higher cross polar radiation pattern. Now what exactly a cross polar measurement tells you? I'll just try to explain that. When in the radiation pattern, when you do a copolar measurement, okay, when you do the copolar measurement, say E copolar measurement, what we are doing? When we are doing copolar measurement, the two E planes are matched in their phi direction. Okay, in their match in their phi and theta direction. After that, in the theta plane, which is the E plane of the antenna, we rotate this antenna so that you measure what is the copolarization component. So here, if this is my transmitter, this is my receiver, the two planes are matched. I am not rotating it like this because that is going to rotate the antenna in the phi direction or orthogonal. So I am rotating it in this direction so that I will measure what is a copolar measurement in the E plane. After that, suppose I keep this transmitter antenna orthogonal. I keep this transmitter antenna orthogonal. In this scenario, what is the received signal at the antenna when the polarization of the antenna and the receiver are not matched? That level tells you the cross polarization component. Now here, if in this scenario, if I am able to receive a good quality signal, then I say my cross polar level of the antenna is higher. Why? Because antenna polarization coming is this way, okay, but my antenna is orthogonal to the incident polarization. But still, from the incident polarization, when the cross polarization contents are there, I am able to extract some signal. So I will define what exactly my cross polar means. It is the ability to receive orthogonal signals. Cross polar level tells me my ability to receive the cross polar orthogonal signal. If an antenna is able to receive the orthogonal signals, naturally a high cross polar antenna, irrespective of the alignment of the antenna polarization against the incident wave, high cross polar antenna will not lead to any signal loss. So in case of circular polarization, what I want, let the antenna be like this, let the antenna be like this. In both the orientations, I should get equal power. So which means that high cross polar or co and cross polar component are not equal in linear or elliptical polarized antenna, but co and cross polar component are nearly the same in CP designs. So this is something very important. I am trying to correlate here the radiation pattern measurement or the cross polar and copolar measurement with respect to the signals which are received in orthogonal planes. Okay, this is something very important. I'll just give you an example so that you can understand this. Suppose I have a dipole antenna. Okay, I have a dipole antenna as a transmitter. I have a dipole antenna as a receiver. So in these two cases, both the dipoles are there, their planes are matched, I will get a proper signal. But if I keep the receiver dipole orthogonal, then what will happen? I will not get a signal. Why? Because the two polarizations are mismatched. But now, if I have a condition, this is my dipole antenna, Okay, and this is my receiver antenna. I am using two orthogonal dipoles at the receiver, and then through the transmission the signal is going a multipath propagation effect, polarization is changed. So at the receiver now, although the transmitter signal is vertically polarized, it has undergone lot of reflections, so the polarization is something like this. But since I have two dipoles at the receiver side, either of the them will receive the signal. I will have a lesser signal loss. Now what exactly this arrangement leads to is a circular polarization antenna, because both the dipoles are working at the same frequency. Okay, they are actually, one is directed along y-axis, one is directed along x-axis. So in either of the condition, I am able to receive both the signals. Okay, so this is what exactly means I should have a circular polarized design at the receiver to avoid a signal loss. So here in this process, I have tried to explain you what exactly the polarization means, what are the conditions to realize circular polarized designs. Okay, then what is the importance of cross polarization in case of radiation pattern what we observe against the CP, as well as the practical conditions where if I use a two orthogonal dipoles, then it ultimately realizes a circular polarized structure. So irrespective of this multipath propagation effects which are there in the channel, wireless channel, and even if the polarization of the transmitter is vertical, irrespective of the multiple path propagation effects, because of the two cross dipoles ultimately realizing the circular polarized condition, I will receive a signal over there. Okay, so in nutshell, to design a circular polarized antenna, you should have a high cross polar antenna design. So this is in linear polarization, naturally the cross polar levels are very low. Okay, if I just want to quantify them, a linear polarized design, LPI will call it as, the cross polar levels are actually less than 30 dB. What it means, it will not receive anything in the orthogonal direction. Whereas in case of elliptical polarized designs, the cross polar level, of course this less than means with respect to the co-polarization level. So in the elliptical polarized design, the cross polar level may be 6 to 8 dB down with respect to copolar level. 8 dB down, 6 to 8 dB down with respect to copolar level. Whereas in CP, here cross polar level are nearly same as copolar level. Okay, that it means that is the difference of the cross polarization component in three different polarization cases. So now we have covered the basics of the polarization, basics of how a radiation pattern relates to the polarization. So in the next lecture now, we will start with the discussion of how these conditions, because see, remember, you have by using this simple dipole case, we come to a conclusion that you require two different antennas. Okay, if I use a dipole, I require two different antennas. If I use a helical, of course, with a proper elliptical ratio in the helix antenna, you can realize a CP. But in case of microstrip antenna, how these conditions are realized using a single patch, we will try to explain that, and we will see various techniques which realizes CP design. So we stop here, we'll start again in the next lecture with the various techniques for CP antenna. Thank you.